Good evening. My name is Kurapati Jayadurga Harshita, bearing roll number 24 BQ180490, second year ECB section. Today my electronic devices and circuits seminar topic is rectification. In this topic, we will know from the basic, from the transformer to the voltage regulator. This rectification topic is very essential in electronics and electrical engineering, especially while designing power supplies from the smaller devices, which is the mobile phones, to the larger company, to the larger devices, the industrial systems. Before going to know that, first let us take the overview of power conversions. Normally, electronic devices require the DC power, whether it is phone or laptop or any electronic devices. But the electricity supplied to our home is our AC. So we need a system that converts AC to DC. Here, the process of converting AC to DC is rectification. This process involves 4 key stages: transformer, rectifier, and filter, and regulator. Each step ensures the clean and reliable power delivery. These are very important in power supplies. Now let us know about block diagram. This is the block diagram of the rectification process from transformer to the voltage regulator. First, an input signal is passed to the transformer. The main job of the transformer is to adjust the voltage. And later, after adjusting the voltage, the signal is passed to the rectifier. In the rectifier, it converts the AC to DC, alternating current to direct current. And the output, this direct current, is passed to the filter. In the filter, it smooths the output and it passes to the voltage regulator. In voltage regulator, it stabilizes the voltage. From each step to step, we will get a clear and clean power delivery and efficient power delivery. So the first key stage is transformer, second is rectifier, and third is filter, and fourth is voltage regulator. Now let us know about the transformer, the first stage of rectification. Transformer. A transformer transfers electrical energy between circuits using electromagnetic induction. It can be step up or step down voltage depending on the winding ratio. This is the first stage in our conversion process. So it works on electromagnetic induction. There are types of transformer. This is a block diagram of a transformer. Here we supply the sinusoidal waveform. It stabilizes adjusts the voltage and gives the output to the rectifier. The transformer are of 2 types: step up and step down. Step up transformers increase the voltage, whereas step down transformer reduce the voltage. For rectification, we use center tapped transformer, especially for the full wave rectification. This is the diagram of a center tapped transformer. Block diagram of center tapped transformer. Here, this is the signal. First, the outer signal is the signal which is supplied to the transformer, whereas the small sinusoidal signal is the output which we will get from the transformer. Here, frequency and amplitude, the frequency remains same, whereas the amplitude decreases. And the next step in the rectification process is rectifier. Rectification means AC to DC conversion. Here we use diodes to block the reverse current. This is the output which we have given, sinusoidal output. We will get the direct current in the rectification process. The key component, this will only allow the current to flow in only one direction, and it blocks the negative half of the AC cycle. By this, we will get the pulsating DC. We will not get the rectification, we will not get the direct output from the rectifier. We will get the pulsating DC. On further passing the filter and the voltage regulator, we will get the direct current DC, which is nothing but DC. These rectifiers are also divided into two types. One is half wave rectifier and second one is full wave rectifier. First is half wave rectifier. In half wave rectifier, we use only one diode. All for only one cycle of one half of the AC cycle is used. It only allows only half of the AC cycle to pass through, but is inefficient and produces a lot of ripple, which because of the production of lot of ripples will it is used in low power applications. So here this is the diode, and here transformer, only one diode is used in the half wave rectifier. This is the sinusoidal output. First is the input waveform. After the passing to the input wave, when the input waveform is passes to the half wave rectifier, it will neglect the negative portion and it will only allow the positive portion. This is the output of the half wave rectifier. Next is full wave rectifier. Full wave rectifier is of two types: center tapped rectifier and bridge tapped rectifier. In center tapped rectifier, this configuration uses only two diodes. So this is known as center tapped transformer. It utilizes both halves of the AC cycle, producing more continuous DC output. So it is very efficient and reduces the ripple factor and reduces the ripple significantly. Here we use only two diodes. And the second type of full wave rectifier is bridge rectifier. It uses four diodes because no center tap is needed in this thing. It is most efficient than the center tapped and half wave rectifier. It is a widely used configuration because providing a full wave rectification with smoother output. Now let us compare the differences between rectifiers. First, half wave rectifier. First, it need only single diode and it is less efficient than the other two. Second is full wave rectifier, which is center tap rectifier. Center tap is which needs two diodes for the operation, and it is moderate, whereas third one is bridge rectifier. It needs four diodes and it is very efficient than the other two, and the ripple factor and ripple is very less than both of these. Better in full wave center tap, better performance but need a special transformer, but whereas a bridge, it is most efficient and flexible. And choosing a right filter depends on the applications. For low power applications we need full half wave, and for more efficient we need bridge wave. So this is the second step. And third step is filtering. Here the purpose of the filtering is it smooths the DC curve, and ripples, it removes the ripples. Here we observe it is the output from the half wave rectifier. First one is the output of the half wave rectifier. Here blue lines represents the ripple factor. Ripples. It removes the most of the ripples here. Output is still, but after passing through the rectifier, output is pulsating DC. It is not a direct DC. So here filter smooths this waveform by removing the most of the ripple. This is very crucial in electronics because that requires stable voltage. So these filters are again divided into four types: capacitor filter, inductor filter, and inductor capacitor filter, and CLC filter. Inductor capacitor filter is also known as L section filter, and whereas CLC filter is also known as pi section filter. Capacitor filter. The most common filter is capacitor filter. It stores the property of the capacitor is it stores the charge. And it stores in the application in the capacitor filter is it stores the charge when it is in peak and releases it when it is gaps. Due to this, it It effectively smooths the waveform. It's simple and effective. It is the most common filter type. Here it works on the mechanism charging and discharging. And second is inductor filter and LC filter and CLC filter, as we have discussed. LC filter is also known as inductor capacitor filter, whereas CLC filter is known as capacitor inductor capacitor filter or bisection filter. Here inductor filter, it includes the inductance in the place of capacitance, and in LC we have both capacitance and inductance, and in CLC we have capacitor, inductance and capacitor. Here CLC is more effective than the inductor filter, capacitor filter and LC filter. Each have its own advantage. Fourth step is voltage regulator. Voltage regulator means even after filtering we will get some voltage fluctuation because due to the load or input variation. Voltage regulator ensures that constant output voltage. Because of constant output voltage, it protects the devices, ensuring consistent performance, protects the sensitive electronics and keeps the output voltage constant. These voltage regulators are divided into two types: linear voltage regulator and switching regulators. Linear voltage regulators are like 7805 and 812 are widely used. They are very simple and reliable and provides fixed output voltage. However, they are very less efficient because they dissipate excess voltage as heat. And next one is switching regulators. These switching regulators such as buck boost and buck boost are more efficient. They use high speed switching and energy storage elements to regulate voltage. They are ideal for battery powered and high efficiency systems. Switching regulators are very efficient comparing to the linear voltage regulators. In summary, transformer adjusts the voltage, rectifier converts the AC to DC, and filter smooths the output because the output which is coming from the rectifier is not a direct DC, so it smooths the output. And here voltage regulator stabilizes the voltage because after the filter also there is some voltage, so it stabilizes the voltage and gives us the stable or DC voltage. Each step is very essential. DC's rectification is very used in many daily day-to-day applications everywhere, from mobile chargers, computers, laptops, and everything is depending on these rectifications because electronic devices are all depending on this rectification process. From smaller applications to the larger applications are very depending on this thing. Understanding this process helps us to design better and safe and more efficient electronics. This is the overall view of the rectification process. Till now we have discussed about the rectification process and the stages of rectification, which are transformer, rectifier and filter and voltage regulator, their functions, their types and etc. Thank you for giving this opportunity.